Today's video will be on Chapter 9.5, Scientific Notation. So this is a form of notation we often use in science, hence the name, but we want to talk about how it is that we get from this scientific notation into standard form, which is just what you're probably used to in math is numbers. And so one way we're going to talk about is the jumping the decimal trick. So this 5 times 10 to the 5th is going to tell us how many times we want to move the decimal. And so if I'm at 6.8 times 10 to the 5th, remember that 10 to the 5th would actually be this number. So if I take 6.8 and multiply by this, I'm going to get a fairly big number, which means I need to move this decimal to the right. Move this decimal to the right 5 times. 1, 2, 3, 4, 5. It's going to put me there. Okay, and then I'm going to fill in these blanks with zeros. And so as I write my answer, or my final answer, and add the comma, I want you to notice that there are oftentimes people are told that this is how many zeros you add. You'll notice there are not 5 zeros, but what I did was I moved the decimal 5 places from where it was. So my final answer is 680,000. So 6.8 times 10 to the 5th is the same as 680,000. All right, now what happens when it's negative? So it's going to be the same idea, but now remember that this, if you remember from our negative exponent lesson, this is the same as 1 over 10,000. So if I were to multiply 3.25 times that, I'm going to get a very small number. So I know that if I move the decimal to the right, I will be making this number larger, which means I'm going to have to move this decimal to the left. So I don't love teaching positive moves it to the right and negative moves it to the left, because I'm going to show you in just a second when that changes. Okay, and so I want you to think of, okay, if this would make this number smaller, in order to make this number smaller, I would need to move left. It's more kind of understanding the concept than it is memorizing a rule. But this is going to tell me that I need to move it 4 spots. Since I'm moving to the left, I'm going to move 4 to the left. So this is 1, 2, 3, 4. Okay, and so I got to fill these in with zeros. And so this is going to be, we often put a 0 in front of the decimal. This is going to be 0.12332 Now I want you to notice again, a lot of times people are learning where this is the number of zeros. It's not, right? You have 3 zeros, and so my final answer is 0.000325. And that is what 3.25 times 10 to the negative 4th looks like in standard form. Now the question is, what happens when you're going the other way? So let's take these two numbers and let's put them into scientific notation. So since my decimal point is here, and since this, as I know, is a large number, I know this is going to be 10 times 10 to the positive something. So as I move the decimal, it's going to be 1, 2, 3, 4, 5, 6. Remember, there has to be a number in the ones place, but there can't be something in the tens, hundreds, thousands. So it has to be a number that's in the ones place, and then you can have anything, or as many as you need after the decimal. So this is going to be 4.1 times 10 to the, and I moved it 1, 2, 3, 4, 5, 6, 10 to the 6th. Okay, and so again, the idea that I had to move, that this is positive, is because this is a larger number, so I already know it. Remember that now I'm moving the decimal left, whereas in this case, right, there was a positive, I moved it right. So it kind of depends on if you're going from standard form or scientific notation. And so that's the idea, and so it's 1, 2, 3, 4, 5, 6. Because it's a large number, I know it's 10 to the 6th. Now, going this way, since this is a small number, 0.000, whatever, I know that this is going to be negative. So this is going to be 1, 2, 3, 4. Remember, it's got to get to the ones place, so I'm going to go to there. So this is 1, 2, 3, 4, 5. So this is going to be times 10 to the negative 5th. So it's 3.2 times 10 to the negative 5th. All right, and the last thing, and how you might use this, or how we use scientific notation in the real world, is I'm trying to compare numbers. And ideally, what I don't want to have to do is do something like this every single time. I don't want to have to change them into standard form and then compare them in standard form. So ideally, I'd like to be able to use scientific notation to compare them. So the question is, which of these numbers is the largest? Which of them is the smallest? Or in other words, let's rank them in order from largest being 1 to smallest being 4. And so the largest number in standard form is going to have to be the one where I move the decimal the most number of places if this is positive. And so even though this is 2.08, 4.38, 6.64, and 1.3, and even though 1.3 happens to be the smallest of those four numbers, this number, 1.3 times 10 to the 11th, is the largest because I will move it 11 times, which means that after I move it 1, I'm going to go 10 more zeros behind that. Okay, and so if I were to put this in standard form, this would be my largest number. Now the question is, what's the second largest number? Well, again, I'm going to be looking at these exponents, forgetting about these numbers over here because in this particular example, they're irrelevant. It's the number, right? I mean, like if you think about, I'll come back to that in a sec, if you think about this, and even if I had that 6.8, but if then I added a bunch of zeros behind it, this number is larger than this number, even though this would also, this is 6.8 times 10 to the 5th. This would be what, 3, 6, 8. So this would be 6.8 times 10 to the 8th. So even though, and sorry, I know it's not a very good 8. Even though this is 6.8 times 10 to the 8th, and this is 6.8 times 10 to the 5th, you'll notice the 6.8 is the same. The difference is the exponent. Because of this exponent, this number is larger than this number. So, when we come here again, we're just looking at the exponent. This is going to be my second largest. This would be my third largest. And then this would have to be my smallest number because of the 5. Right? So even though 6.64 may be the largest of all of them, 6.64 times 10 to the 5th happens to actually be the smallest of all of these numbers. Alright, that's all we got for you on scientific notation. Thanks very much for watching the video. Don't forget to do the problems on the bottom of the page. I'll see you in class.